Okay, I'm ready to get the vise number 2 machined. I've got our program loaded up here. We did a simulation on the screen and everything looks correct. I did a quick air cut through here to make sure everything looked good, and it did. So I think we are ready to go. I need to adjust my coordinate back down to 0, and I need to adjust my coolant. I'm gonna do that next, get that off camera, and we'll be ready to go. I wanted to note that we have 1/4 inch parallels in there to gap the jaws the way they need to for the program. Because this one, I wanted just a little bit more opening on this, so we reduced it. This one was set at 3/8. We're going down to 1/4 inch on this just to give the opening a little bit more there. So we're going to be running a 2D adaptive to rough out the pockets for this, and then it's going to do a contour pass to clean up the bottom and the sidewalls, get it all cleaned up, and then we're going to do a chamfer operation, get all the edges chamfered. And what we'll do is, if in the event that I need to open up the pocket a little bit more, say like 1/1000 or 2/1000, probably max, we're going to have a separate program that I can load up and run with cutter comp and adjust it however we need to kind of open up, and we'll make one pass on the dynamic jaws here. The dynamic jaws are where the profile of the drill index is going to be. So the fixed jaw will have a straight pattern, a straight cut all the way through there. The dynamic jaw will sort of have this radius on both ends of it to capture the drill index and keep it centered up. So in the event that it's tight, we can run cutter comp, run just this one contour pass on each one of those jaws to open it up a little at the time. I think that covers it there. So we'll go ahead and get started on this guy. I wanted to give you a quick preview of our Fusion program here and what this will look like once we're finished machining. So this is what it'll look like. We have our soft jaws that we're machining, and this was another great training exercise, another learning experience for me, where Kevin was showing me how you take your design that you're wanting to machine and import another design on top of that. In our case, it's our drill index. So I've got them unhid. So if we unhide them now you can visually see them on top of the vise, right? And he taught me just the proper techniques that you have to use in order to make the shape that you want in your soft jaws. So this worked really great. We made a few adjustments here, like around on these corners right in here. Let me see if I can rotate that around. You know, like this corner right here. We didn't want this to come to a sharp point, so he suggested put a fillet on there. So that way it's not sharp. We've got a nice radius that sweeps around that you don't hit your hand on. And then just like over here on the other side of the jaw, you know, we added a couple of chamfers here to break that edge off so you don't have a sharp edge and it's deburred. All right, some really cool stuff. So yeah, that's what it's going to look like once it's done, and I'm really excited to see this. And we'll come over here to the design, I'm sorry, the manufacturer side of it, where we have our cam. All right, soft jaws op 2. So this is going to be the main operation. We'll hit a simulation. This will take a while to go through there, but you can see this is what we're going to use that 2D adaptive to machine the pocket out of there. All right, and then once we have both sides pocketed out, we'll go to the next operation. We're going to do that was the 2D adaptive. This is 2D pocket to clean up the bottom and go ahead and clean up the sidewall a little bit. We left a little bit of material there to clean up, so it'll do both sides of that. And then we're going to go to another contour. Right here is going to make our 10th cleanup pass down the wall. And then we go to another 2D contour to machine the chamfers on the top of the jaws there and on those lower edges as well. Get that cleaned up. And then that'll be the end of the program right there. So what we did is we copied the 2D contour for the finish pass that cleans up the wall, and we just copy and pasted it down here. So if we come down here to this contour pass, in the event that the drill index fits in there a little too tight in this radius, if it's a little too tight and it's trying to like squeeze on it, what we can do is use our cutter comp on the machine, adjust it by, I don't know, 1/1000th of an inch if we need to, and just run this one contour pass. And what it'll do is just go right down the pocket, the radius part, the dynamic jaw, should I say. We'll simulate that and let it run through. the blue's in there because it's, you know, it thinks all the stock is back in there. But yeah, we could just run that contour pass to clean up both of those jaws there and open that up just ever so slightly if we need to, just depending on how it's clamping on to the drill index. Because at this point, once we put it in this vise, that's going to be a machine face on a finished machine face. And my goal is to not mar up the side of it. I got one right here in front of you. So our goal, once we set this down in there and we clamp on it, is I'm hoping that it does not leave any marks here on the side of the drill index. So we'll have to just see how it reacts and adjust it accordingly. So anyway, that's a rundown, and I think I'm ready to start seeing some chips fly. So let's get back out there to the Miltronics. We got our coolant adjusted. We're ready to go. Just going to bring this down nice and slow and make sure that we're in the right spot. It looks like it is. I think that's right. All right, I got it at 100%. The chip packing in there is definitely a big concern. It's not right. This is one of those things that I'm having to learn and figure out because I can't open the door. I can't blow them off. I can't blow them off with coolant. So I think I'm going to try to halt the program whenever we get through this first dynamic jaw and see if I can figure out how to properly halt it, open the door, clear the chips, make an adjustment on our coolant, and continue going. Okay, I was able to hit halt. I'm always afraid I get this wrong because I haven't had good luck doing this. But it is letting me halt and open the door. And I think I'll be able to restart it. Go ahead and try to get some of these guys off of here. Matter of fact, I'm just going to rake them down. Get them out of the way, make some more room for the next batch of them that's coming out of the vise. Halfway through our second jaw, it looks like our coolant is working better this time. Applied a lot more pressure to it to help wash them away, so hopefully that'll continue. All right, this is going to be the 2D contour cleanup pass. It's going to clean the bottom up. We left 10 thousandths in the bottom. I'm sorry, we left 20 thousandths in the bottom to clean it up. And it'll take 10 thousandths off the sidewalls. And then it'll come back, the final pass, it'll take another 10 thousandths off the dynamic jaws. Hopefully this will leave a nice, smooth, pretty finish in the bottom for the drill indexes to sit on. Now we're on our final contour pass, just cleaning up the sides of the jaws. All right, time for a tool change. I'm going to take this nice and slow, just to be sure everything's good to go. pretty good. Should be cutting. We got a 10 thou chamfer brake on all the corners. I'm going to go ahead and apply the coolant so it'll help wash some of those chips out of the way. If it's going to go to the other side. So after it gets the top of the jaws, it'll go down to the bottom edge and break those edges as well. Yeah, it worked, Kevin. It amazes me that it just won't crash into the shank of the cutter there. If everything lines up right, there's 1/1000th clearance between the cutter and that vertical wall that it comes up next to. That is it. End of the program. Awesome. That portion of it took a half hour to get done, 30 minutes. Jog everything over here toward us. Let's give it a little peek, see what it's looking like. I just want to kind of give it a feel. Oh yeah, boy, that feels great. That cleanup pass looked good. Our chamfers look good. I'm happy with it. Everything's deburred. There's no sharp edges. That thing is ready to go to work. What do you say we give these guys a test fit? Got everything cleaned off. I need to get the parallels out of there. For our test subjects, we're going to be using a couple finished, but these are in my blend pile because they got scratched in anodizing. There's a scratch there. There's some scratches on the bottom right there. It's fitting nicely. And then our other blim, we've got a pretty good scratch right there. So this is just something that's going to be happening. You know, you can't expect every single one to be absolutely perfect. And we're also going to have to deal with probably some of them getting damaged in shipping. But we'll cross that bridge whenever we come to it. Seems like it's fitting nicely. So what I want to know is if I tighten up on this guy, if it's going to stick to that pocket on that dynamic jaw. It's going to bring the front jaw in, and then it's going to bring the rear jaw in, and then it'll tighten. All right, that feels pretty tight. Give it some torque. It looks good. Now let's back it off. It'll open this one up first, and then it's going to open the front jaw. I believe it moves 1/4 of an inch. All right, it didn't stick. So, you know, I think it may be good. I don't see a mark on the anodized surface there. I'm going to do it one more time. It looks like it's going to be good to go. Crank down on it. Looks good. We may not have to use any wear comp or cutter comp. I mean, oh, see? Nope, it didn't do anything there. But we may not have to do any cutter comp and open that pocket up. It feels like it's working just as we were hoping it would right out of the program. I'm happy with it. I'm really, really happy with this. And I just wanted to extend a thanks to Kevin for always helping me with this stuff and making sure that this is right. He's always super confident that this is going to work without any issues. And I think he's been right just about every time. The only errors I've made is just on my end where I didn't do something correctly. So let's run through a quick little simulation of how this setup's going to work for us. So pretend these are finished, machined in op 1, and maybe there's already some in here that we had taken out. So these get pulled out. And we'll take these and flip them over like this onto this side. And then now over here on this vise for op 1, we've got our stock that we're going to set in here. One thing left that I need to do, I'm just going to do it off camera, is I'll drill and tap the side of the fixed jaw here and put some kind of piece of metal across here to create a stop against the bottom. Probably do that over here on this side. So we'll set the stock in there, push it left against the stop. We've got our second workpiece. Push it against the stop. And now we can just tighten everything up. All right, so that'll be torqued down nice, and then we come over here and torque down our op 2 vise. Just like that. And it is ready to hit cycle start. Real happy with the outcome here. It looks great. I think this is going to be a really nice improvement on what's going to be our third batch of drill indexes that I'm getting set up to start on. So this is really nice. I'm loving it. Got to thank the guys at Tico for helping me figure out a really nice work holding system. And I love these vices here. These are going to be really handy. And of course, we can continue to use these jaws for other jobs down the road. Maybe we have another drill index that we use them for, I don't know, or a separate job. We can machine the other side once we flip them around. All right, so big thanks to Tico for helping me figure out the vices. And of course, our Miltronics VM is going to do an excellent job. We have higher RPM. We're going to a 10,000 RPM spindle versus the 8,000 on the TRM. Side mount tool change, so fast tool changes, and through spindle coolant whenever we use that. I'm going to see what kind of tools I can adapt for machining this that we can upgrade to have through tool coolant on there and help improve that. So anyway, that's it. I think we're going to wrap this up, and I am ready to get started on production. That's the next step for me here on the VM, is start wrapping up some or getting started on some production of our A-Bomb 79 drill indexes. I hope you guys enjoyed watching the video. Thanks for coming along and being a part of the journey. I look forward to continue sharing that with you. All right, guys, we'll see you later.